Hello friends, welcome to New Lessons. Today we will discuss about basics of MATLAB. As an engineering student, you must be aware of MATLAB. It's a highly computing device, or you can say it's a necessary software for all the branches of engineering. It doesn't have any branch passes like CSE or EEE. All sorts of branches has its uses. So we'll start with the basics of MATLAB and introduction to MATLAB. So first of all, when we start MATLAB, we see this window, that is what we call the display window. You can see the red color box. This is known as the command window. Any sort of commands you want to enter, you can enter over here, or data and results will be displayed. On the left hand side, the blue box contains the workspace, which lists all the variables you are using, and below that the green box is the command history. It displays all the logs of commands that are used during your execution of the program. So as I said, it is a software for technical computing or very high level computing, so it can be used from very simple arithmetic uses to image processing, digital processing systems. But for the time being, we will start with only the basics. First of all, we have discussed about the display windows. Now this display window has some different types of windows, like the graphic figure window, which displays plots and graphs. Here is a command, surf magic 30. It is used to plot or make a graph. It is created in the response to graphical commands. There is a M file editor or a debugger window. It helps in create and edit scripts of command called the M files or the MATLAB files. Now the very important and general thing is getting help. Suppose you get stuck with some keywords or you want to know about something. How can you get help from MATLAB? Just type help on your command window and it will list all the topics help. If you type help and the specific command name, it will provide the help for that specific command. And if you type help, then it provides how to use the help command in MATLAB. So this is very useful. MATLAB has lots of things to learn. Nobody can mug it up or remember all the things. So generally, being a regular use of MATLAB, you will be using this help command also. Now let's talk about some variables used in MATLAB. As you are quite aware of C programs, so a variable name must start with a letter. It may contain any letter, digits and the underscore. But you must remember, MATLAB is case sensitive. That is, a small letter and capital letter are different variables in case of MATLAB. So you need to be very aware about typing those things. You must be very aware of case sensitive typing in MATLAB command window. Now next we have the assignment statement. In general we assign something like variable to a number or a variable to an expression. So here also it is very simply used in this way. Here I have shown you an example. Like in case of MATLAB window, you will find this sign. That means your command window is ready to accept the command, and then afterwards it will display the output. So whenever you see this command, that means your MATLAB is ready to use the command. We can write x equals to 1 2 3 4. It takes the value as 1 2 3 4. The right side of the part is assigned to the left side of the variable. These are very general concepts you have learned in C or C++ also. But always remember, whenever you place a semicolon, the result is not displayed. That means I will show you in a demo. For the time being, just see x equals to 1 2 3 4 terminator or the semicolon, and next is x equals to 1 2 3 4. So the difference between two is, where you have put semicolon, the output will be not shown until you request another command for showing the output. But in case of x equals to 1 2 3 4, it will automatically show the output of x, that x has stored a value 1 2 3 4. Now moving to some more variables. These are called spatial variables. One thing I want to tell you, whenever you save the MATLAB file, never save with a keyword name. That will create a lot of problem when you will search for that file or when you want to run that file. Never save with a keyword that is used in MATLAB, and always try to save with a different name, giving different digits with numericals and underscore. That will be very helpful to organize all your files in a particular good way. So coming back to these variables, here we have 2 to 3 types of variables generally. Answer, A and S. This is the default variable name for the result we show. That is, the MATLAB shows the variable output that is known as A and S, answer. Pi. Pi is by default 3.1415 is by default given, present in MATLAB. Epsilon, you can know 2.22, smallest amount by which two numbers can differ. INF means infinity. NaN means not a number. Very often this comes as an error, or you will know after you use this NaN, not a number. Now talking about some vectors, matrices and linear algebra, we have terms like vectors. Example, how will you input a vector? For example, whenever you see this sign in MATLAB, you need to write as x equals to 0 space 0.25 into pi space 0.5 into pi space 0.75 into pi and finally pi. So in this case, as we have not put any terminator outside this box, so it will show all the things in one line, that is x equals to 0, 0.25 into 3.14 and so on. So this is what we call a row vector. Now suppose we put terminator after each digit. When we analyze from left to right, after each terminator the line ends and the next line starts. So this gives you a column vector. Now knowing something more about these vectors, vector addressing. A vector element is addressed in MATLAB with an integer index enclosed in parentheses. Suppose I write RAND parenthesis 30. It will display randomly 30 numbers. Now suppose I write x3. The answer will be 1.57. And you will wonder how this answer came. So let me tell you. In our previous row input, we have used it like this. So in this case 1, 2, 3, the third element was 1.54, and in this case also 1, 2, 3, the third element is 1.54. So but we have written x is x of parenthesis 3, so it will display the third element of x vector. So this displays the third element of vector s, that is 1.57. Now this colon notation may be used to address a block of elements. We can also write it like start, then increment, then end. Start is the starting index, increment is the amount to add each successive index, and end is ending the index. In short form, we can eliminate this increment. We can just write start and end, and that will be incremented by 1 by default. Now for example, if you see x parenthesis 1 colon 3, that means it will start from 1 and end till 3. All the three elements will be displayed, 0, 0.78 and 1.57. From first to third elements of x vector is displayed here. You need to remember, MATLAB index starts from 1 and not from 0. Many of us are confused also sometimes, but MATLAB index always starts from 1 and not 0. Now here are some more vector commands. You can see x equal to start colon end. It will create a row matrix, row vector x starting with start, counting by 1, ending at n. In this case, the increment value is not assigned, so by default it will take 1. If you assign an increment value 1 or 2, then it will take it as usual. So see the second one, start, increment, end. It will create a row X starting with start and counting with the number of increment you want. Line space, start, end, number, create a row vector X starting with start, ending at end, having number of elements. Length X, it will give you the length of the vector X. Y equals to X dash, apostrophe of X, that is the transpose of X, dot X comma Y returns to a scalar product of vector X and Y. So these are some basic vector commands you will be using for the first time. Now some simple idea about matrices. You are quite aware of matrices. Matrices are formed with row and column numbers. It is a two-dimensional array having both multiple rows and columns. It begins with, you can see like this, and end with a parenthesis. The whole matrix is kept in a parenthesis box. Spaces or commands are used to separate elements in a row. Semicolon is entered to separate, used to separate in rows and columns. Suppose A is an n cross n matrix. Now m is the number of rows and n is the number of columns. You can see like this. This A shows m cross n matrix. This is the main diagonal, and the other diagonal is the off diagonal. Now how will you input these numbers? Just remember the basic thing. For inputting in row, we need to write 1 space 2 space 3, and when you want to end the line and sweep to the next line, then we need a terminator. So if your matrix, if you want your matrix to be like this, you need to write 1 2 3 semicolon 4 5 6, and it will come down to the next line. In this way we can input any number of 2D matrix array. Now matrix addressing, we need to write the matrix name, row and the column. Colon may be used in space of a row or column, a reference to select the entire row or column. For example, if I write f of 2, 3, that will give the second row and the third column. Which is the second row and third column? The element you will find, that is 6. In the previous example I have shown 1 2 3 4 5 6, second row third column, so it is 6. Now suppose somebody writes h parenthesis colon comma 1, that means it will give the first column only. It will start from 2 and 1. So I think this has given you a very nice idea about using little bit numericals or matrix or vectors in MATLAB. Now we will see how to use this transpose. Here are some basic commands of matrices. B equals to A transpose. Identity matrix, we write a special command or a keyword, you can say EYE of n, returns a n cross n identity matrix. If you write EYE m and n, it will return m cross n matrix with ones on the main diagonal and zeros elsewhere. That means it will have a principal diagonal filled up with 1 and other elements as 0. And simple for arithmetic addition and subtraction, we have a plus b, a minus b. Scalar multiplication, we have b equals to alpha into a. For matrix multiplication, we multiply both the two of these vectors, c equals to a multiplied by b. Now for calculating inverse, we use inv as a special command, inv of matrix A. But in case of inverse matrix, you should remember the matrix which we are using. Suppose in this case we are using A matrix, that should be square matrix. Now if you want to have the powers of matrix, we will write a dot, you can see this sign, to the power 2. This means the matrix, all the elements of this matrix will be squared. Suppose we write C equals to A star A, that is A multiplied by A computes A into A and A be a square matrix. For calculating determinant also, A must be a square matrix. The command used is det of the matrix name, that is in this case we are using A. Now some idea about the solutions systems of linear equation. You all are familiar with three linear equations with three unknowns. Here is an example: 3x1 plus 2x2 minus x3 equals to 10, minus x1 plus 3x2 plus 2x3 equals to 5, and x1 minus x2 minus x3 equals to minus 2. So in this case, what we need to do, we need to find the desired values of x1, x2 and x3. So in this case we have ax equals to b. So for finding x we need two formulas. We can have it by inverse method or by direct division method. So by inverse method we will write x equals to a inverse of b. Now in case of MATLAB, now you can input the two vectors like a and b. Suppose I have input the a as 3, 2, minus 1 from the previous equation, and minus 1, 3, 2, 1, minus 1, minus 1, and respective b's are 10, 5 and minus 1. Always remember, a is a matrix form and b you have to write in column vector. So to find x equals to inverse of a multiplied by b, we will write inv of a into b, and we will get the answer as minus 2, 5 and minus 6. Similarly, we have another method, that is by matrix division method. In this case we will write ax equals to b and x will be b divided by a, that is a left division. In this case also similarly we use, but the function here will be x equals to a left division of b. The answer comes up to the same. You have to remember one thing: for left division and right division, a slash b means b is divided by a, and in right division we write as like this: x slash y, that is x will be divided by y. Now we have some logics like flow control, if and else. Example of if and else clauses: if my efficiency is greater than 100, then display excellent. Else if my efficiency is greater than 90, display appreciable. And for the next else, display needs to improve. So in this case we can use many cases, many else cases or if else cases clauses, so that we can run our program effectively. This is just a flow control in case of MATLAB that is used. We can also use loops like the for loop. In case of for loop we have for variable equals to expression, then we write the desired command and end it. For while loop we write while the given expression and the commands, then end it. And the next is the example of both. You can see, for variable equals to expression we write something as t equals to 1 to 5000, y of t equals to sine of 2 pi t by 10. In case of while loop also we write EPS equals to 1, while 1 plus means in this case first the expression is checked, then the command is run, then it comes out of the loop. So both have their advantages and disadvantages, but the most used one is the for loop. We also have some break statements in case of MATLAB. It is used to terminate the execution of the loop and comes out of the loop. Now there are some ideas about plotting graphs. We can also plot graphs and see, and we can have a good graphical analysis in case of MATLAB. For this we need to plot like this. If you want to name the label or x and y axis, you need to write x label equals to what you want to type, y label equals to a. Suppose in this case it has been written as y label equals to a of s and x label equals to s. Eventually you will learn. The more you will practice, the more new things you will explore, and it will be very interesting for you. Now suppose this is a simple example. In the next video we will study or discuss about how to use it actually in real time in MATLAB. For the time being, just you need to remember, suppose I write this command, t equals to line space minus 5 101 x of cos t, y of sin t. These two simultaneously makes a helix structure. So for plotting this we need plot 3 x, y and z and box on to make a box. So the output for this is like this. This is a real-time MATLAB output. You can see the diagram is a helical structure. So there are many uses in MATLAB, from simple arithmetic to control system, from electrical system to image and digital processing. So we need to study about MATLAB from the very beginning in order to get more idea about it. In the next video we will learn about how to use it in real time. Thank you.